We are live. Hi everyone, welcome back to Codera. Today in this video, we'll be discussing the LeetCode daily challenge for 8th of Feb. The name of the problem is add digits. Previously, this problem has been asked in Microsoft, Amazon and Adobe. So consider giving me a +1 in the chat if my voice is clearly audible and the screen is completely visible. And then within a couple of minutes, once everyone else joins in, so we'll be starting this problem. This is an interesting problem because we have a very good brute force approach for doing this problem, as well as we'll be learning some observations, like how to do observation in a particular problem. For achieving the order of one solution, we'll be learning how to do the observations in a problem, right? So give me a +1 in the chat if my voice is audible to everyone. Also hit the like button so that we can start as soon as possible, right? You can just let me know in the comments. Right, so this particular problem, as I said, it has been asked in companies like Amazon. So this problem has been asked in Amazon. It has also been asked in Adobe. Hi Samadhan. It has also been asked in Adobe and it has been asked in Microsoft. So these are the three companies that have asked it popularly, right? So let's discuss this problem. What does this problem say? Hi Deepak Bist. So this problem says that you will be given a number n, right? You will be given a number n, right? So they are saying that you will be given a number n, and what you have to do is you have to repeatedly add all its digits. You have to keep on adding all its digits until the resultant number becomes a single digit number, right? Let's say if I have been given 38, if I have been given a number that is 38, if I have been given n is equal to 38, right? So in this case, what I should do is I should add these digits. So if I add these digits, what will I get? I get 3 plus 8, and that will be nothing but 11. So I can see that this still the number is 11. It's not a 2-digit number. It's not a 1-digit number. It's still a 2-digit number. And I should keep on adding the digits until I get a 1-digit number. Now what is happening? The number is 11. Now I add its digits. So I add 1 plus 1. So I get nothing but 2. So I am getting 2 as the single digit number, right? Is the problem statement clear to everyone? You will be given a number. You keep on adding its digit unless and until you receive a single digit number. Like if you have 38, so you add 3 plus 8, you will get 11. Once you have 11, so you add 1 plus 1, so the digits of 11, so you will get 2, and then you will stop your procedure, right? Does this make sense to everyone? Right, this particular approach. Now let's take another example for this case. Let's say if my n was equal to something like 188, something like this. What if n was equal to 188? Then in that case, what could have happened is I would have done 1 plus 8 plus 8, and that could have given me nothing but 17. Now I see that this number 17 is something which is greater than which is not a 1-digit number, right? So n is equal to 17. If I have 17, so I'll add its digits. 1 plus 7, it will give me nothing but 8. So now I'll stop because now I have a single digit number. Does this make sense to everyone? I hope it does, right? Let's take a bigger number, maybe in which we have to do several iterations. So maybe let's take a number like let's say something like a 699 or something like that. Let's take this number and let's see what will happen in this number. If my n is equal to this, so this would be equal to 6 plus 9 plus 9, so that would give me 18 plus 6, so that is 24, right? So if I have the number 24, so what I can do with 24, 9 plus 9 is 18, and 18 plus 6 gives me 24. So 2 plus 4 is the number, it will give me 6. So finally the number would be 6 if it is reduced into the single digit number. So you keep on adding the digits unless and until you get the single digit number, right? So what you can do is for this you can always try a brute force approach, right? You can try for a brute force approach. You can try for a brute force approach. What is that brute force approach? The brute force approach is that you always take out the sum of the number, right? If the number is having more than 1 digit, then you always keep on taking out the sum, right? Like this, like while the number is greater than 0, this is for taking out the sum. So sum plus is equal to nothing plus but number divided by modulus 10, and I keep on updating the number mod is equal to 10, right? I keep on doing this, and then what I do, I update my number. So number is equal to sum, because whatever the sum was, it would become my number. Like if I had something like, let's say something like a 99, so I'll get what, 18. So this is the sum that I'm getting, and this will be the new number. So that's why I'm assigning it to the sum, and I'll have a while loop where I would be checking if it has more than one digit, so I'll always keep on doing this, right? Let me show you the code part for this approach, what exactly I mean. If the number is greater than 9, so that means if the number is a 2-digit number, if the given number is a 2-digit number, then what you will do, if the given number is a 2-digit number, so then you will keep on doing this process repeatedly. What you will do, if the number is greater than 0, until then you will be finding its sum, right? So sum plus is equal to the digits, that is the number modulus 10. This will give you digits. You will keep on adding the digits and you will keep on updating your number, right? This function is to find the sum of the digits of the current number. Then what you will do, you will assign your num is equal to sum, because whatever sum you were having, that particular sum you will assign it to the number, right? If you have something like, if you have 99 as the number, then you are getting the sum as 18, and that would be your new number. So that's why you will update your num to sum, right? And then you will mark your sum to 0. Why you will mark your sum to 0? The reason for that is very simple, because you will again want to calculate the sum from the start, right? If it's clear to you, you can give me a +1 in the chat, and also please like the video if this approach is clear. Now the same approach is in Java. I have provided the code for brute force approach for Java and C++ both in the description of this video, right? Now the thing is that the approach that we are doing is nothing but what the question is saying, right? That was a brute force approach, and that will not be optimal if we have a lot of, if the number does not keep on reducing. If suppose if the number is such that you take a lot of steps to get it, right? Why setting sum to 0 in the end? Why setting sum to 0 in the end? Why? Because like if I have a number, let's say 99, right? If I have the number as 99, then what I'll get? I'll get the sum as nothing but 18. I'll get the sum as 18. Now my new number should be what? The new number should become sum, that is 18, and my sum should become 0. Why sum should become 0? Because in sum I am storing the sum of the digits, so that's why sum should be equal to what? 1 plus 8. So it should not have anything previously, then only I'll be able to update the sum, right? It should not have the previous 18 number, right? It should start from the beginning. So sum should become 80, so that I can add, like, first of all, sum plus is equal to 1, so that sum becomes 1. Then I'll do sum plus is equal to 8, so it becomes 1 plus 8, that is 9. So then the sum would become 9, and after that what I'll do, I'll say that okay, num is equal to sum, that is number is equal to 9, and I'll mark my sum as 0, and the number is 9, so that's why it's a single digit number. Then I'll stop, right? Himnish, is this part clear to you? Nirvan, I hope that this part is clear to you, right? I hope this much part is clear to everyone. I can see a lot of people are watching, so you can consider to like this video, right? Now there is a second approach for this, right? There is a second approach for this, but it's an observation based question. It's an observation, right? Approach 2 is based on observation. Like, you want to do, can you do it in order of 1? That's the thing. How can you do it? You can do it using the observation part that I'm going to tell you. What you can do is, if you will observe, let's try and observe. If the number given to me was 0, if the number was 0, then what will happen? The sum of digits would be nothing but 0. If the number was 0, what if the number was 1? If the number was 1, then the sum of digits would be 1. If the number was 2, then the sum of digits would be 2. If the number was 3, then the sum of digits would be nothing but 3. If the number was 4, the sum of digits would be nothing but 4. If the number was 5, so sum of digits would be 5, like this. If the number was 9, then the sum of digits would be 9. Right? This much part is very much basic. This much part is basic. But let's check for the others. Let's check for the other things as well, right? What if the number was 10? If the number was 10, then what will happen? If the number was 10, in that case the sum of the digits would be 1. If the number was 11, then the sum of digits would be 2. If the number was 12, sum of digits would be 3. If the number was 13, then the sum of digits would be 4. If the number was 14, then the sum of digits would be nothing but 5. Try to observe. Can you observe something? Let me know if you are observing something. Also, you can like the video, right? Now, if the number was 15, then what will happen? If the number was 15, so the sum of will be 6. If the number was 16, then the sum will be nothing but 7. If the number was 17, then the sum would be 8. If the number was 18, then the sum would be 9. And if the number was 19, then the sum would be 2. Does this make the sum would be nothing but 1, sorry, 1, right? Not 2, 1, right? Can you observe something? Can you observe something from this? Let me try to introduce another row. Let's say n is equal to 20. If the number was 20, then in that case its sum would be 22, right? If the number was 21, then what will happen? If the number was 21, then I'll get the sum as 3. If the number was 22, I'll get the sum. I'm taking this time so that you can understand, you can observe the pattern. Whenever you are observing a pattern, so you need a list of observations, like you need to observe a lot so that that observation is consistent. That is why I'm drawing this. So n is equal to 22 would be, the sum would be 4. N is equal to 23, the sum would be nothing but 5. For n is equal to 24, the sum would be nothing but 6. The sum for n is equal to 25 would be 7. For n is equal to 26, the sum would be nothing but 8. For n is equal to 27, the sum would be 9. For n is equal to 28, the sum would be nothing but 10, that is 1, right? And for n is equal to 29, the sum would be nothing but 2, right? Does this make sense? 9 plus 1 is equal to 1, where like it would be 10, and then like the number would be what? 9 plus 1 would be 10, and then 10 is nothing but 1 plus 0, so it will give me 0, it will give me 1, right? That's why I'm doing this, right? Can you observe a pattern in this? Can you observe a pattern? Let's try and observe a pattern. Observe a pattern. I'm highlighting something for you. If the number was 9, then the sum was 9. If the number is 9, then the sum is 9. If the number was 18, if the number is 18, then the sum is coming out to be 9. You can extend this table, for further numbers as well, but you will get only these sums, right? Because if you want a single digit, then in that case the answer would lie in the range 0 to 9, right? Ultimately. So this is the ultimate answer that you will get with regard to any digits, right? So what I'm saying is you observe something. If n is equal to 9, so the answer was 9. If n is equal to 18, so answer is 9. If n is equal to 27, then the answer is 9. What if n is equal to 36? Let's check out. If n is equal to 36, then the answer would be 3 plus 6, that is 9. If n is equal to 45, then the answer is 9. What if n is equal to, let's say, 47? Then the answer is what? Then the answer will be what? This answer would be nothing but, this would be 11, so it would be 2. Can you observe something? If number is lesser than 9, then you will return the number you are saying. Yes, that will be the case. But can you observe something? What is 9 mod 10? What is 10 mod 9? What is 10 mod 9? What is 10 mod 9? Can I say that 10 mod 9, if whatever number is given, if I do number mod 9, can I say that I'll get this, get the sum? Can I say that I'll get the sum that I require, the single digit number that I require? If let's say I have 23, so 23 is nothing but 6, and I do 24. If 24 I have, 24 gives me 6. So 24 mod 9 will give me what? 2, right? I'll get what? I'll get no 24 mod 9, I'll get 6, right? Whatever, if the number is greater than 9, then I will just do whatever is, irrespective of the fact that it is a 3-digit number, 4-digit number, any number. I can observe that the final answer lies in the range 0 to 9. So I can say that if I take mod 9, then in that case I'll get the final digit, right? The single digit. Please give me a +1 in the chat and like the video if you have understood this part. If you have understood this observation, like you can see, if the number was 9, let me make you observe this part, right? Let's observe this part again. Let's observe it. So if let's say the number was nothing but 18, if the number was 18, then the sum that I was getting was 9. If the number was 19, then the sum that I was getting was 1. And 19 is nothing but 19 mod 9 is equal to 1, right? Now next up, what will happen? Next up, if you have n is equal to 20, so what is this? This is nothing but 2 plus 0, that will give me 2. I know that, but how will I get it? 20 mod 9 is also equal to 2, right? This is how I'm getting it. Now this is the thing that you need to observe. If a number, the answer can be in the range 0 to 9. The answer can be in the range 0 to 9 always. So that is why what you will do is if you take mod 9, and if that number is divisible by 9, so that means that the sum would be 9 ultimately, right? Otherwise, if the number, let's say the number is 30, so then the sum of the digits would be 3. But what is this 30? 30 mod 9 will give me what? 9 3s are 27, and then I need to add 3 more, so the remainder would be 3 here. So this is what I'm getting, the remainder of the number with 9. Please give me a +1 in the chat if up till now things are very much clear to all of you, right? This is what I'm doing. So this is the thing that if n is equal to 0, this is an edge case. This is an edge case because if n is equal to 0, then the sum of the digits would be 0. So if my n is equal to 0, in that case I'll return a 0. Now if my n is divisible by 9, right? If the number is divisible by 9, let's say if you have 18 mod 9 is equal to 0, but you need to print 9, instead of 0. So if the number modulo 9, if the number is divisible by 9, I will try a 3-digit number as well. Just give me a minute. Number mod 9, if it is equal to 0, then what you do is you return a 9. If the number is divisible by 9, in that case you will not return the modulus, because the modulus would be 0. The remainder would be 0, but you need to return 9, right? Like 18 mod 9 would give me 0, but actually I need to return 9, right? 27 mod 9 would be 0, but I need to return 9 in this case, right? Else I'll return the number modulo 9. Right, let's try for a 3-digit number. Let's try for the 3-digit number as Lalit has mentioned it. Like, let's try for a 3-digit number. Let's see what will happen. Let's say if I take something like, I take a bigger number. Let's say I take 7, 8 and 9. Okay, if I take 789, if I'm taking this number, so let's try and observe what will happen. Let's try and do it the brute force way. So initially the number is 789. So I'll decompose it. So 7 plus 8 plus 9 will give me what? This gives me nothing but 17, and then say like, you can correct me if I will be wrong. Now this will be 17, and 17 plus 7 would be nothing but 24. Okay, so now the number would become nothing but 24. If the number becomes 24, then I'll do it again. So 2 plus 4 would give me 6. 2 plus 4 gives me 6. So let's observe what will I get. I'll get here the number 6. So ultimately I should get 6, right? But I am doing this as a brute force way. Let's try and see what I will get as the remainder. Let's try and see. So I have 9 and I need to divide 7, 18, 9. So 7, how many times you will take? You will take, like, this would be 72. 9 8 is 72. Like, this would be 8 here. That does not, the quotient does not matter to you. Now this would be 69. Now if you have 69, then what you can say, you take it 7 times. So this would be 63. So ultimately you will get 6 as the remainder. The remainder is nothing but 6. Can I say that the remainder is 6? Can you observe this part? That the remainder is 6, and that is what our answer was actually. Right? Can you observe this? Let me try and take another example for all of you. Let's say if the number was something like, let's say if it was like a 9, and then let's say something like this, 729. Let's take 729 for that matter. If I take 729, right, if I take 729, then what I'll do, I'll have, like, the number would be initially 729, right? I hope that the explanation is very much clear to you. Please write clear in the chat if it is clear for the 3-digit and higher digit numbers as well, right? So you have 7 plus 2 plus 9, so that would give me what? That would give me 18. So I'll say, okay, the number would be 18, then 18 is what? 1 plus 8, so that gives me 9. So the number is finally 9. Let's try and observe if I'll get this particular number as well or not in my answer, if I'm doing it using the modulus concept. So if I do 9, and if I have the number 729, so this would be 8 times 9 8 is 72, so I get this, then I get 9, then I take 1 time, so this would be 9, so I get 0. If I get 0 as the remainder, then the answer would be 9, as I have told you. Got it, bro? It's number property. We are not doing anything extra. Classic and faster approach. Yeah, this is very much basic, very basic approach. This is nothing but observation. Right? You can try it for other cases as well. It will work for any case. You name it and it will work. For any case. If you take, let's say, n is equal to nothing but 28, let's say if you take 388 or something like this, if you take this example as well, right? So what will happen? Like, if you take this example, so it would be nothing but 3 plus 8 plus 8, so 16, and this would be 19. But what will happen? The number would become 19, then the 19 you added, so this would become nothing but 10, right? After this 19 would become 10, right? This 19, that is 1 plus 9 would become 10, so the number would be 10 after that. Then what will happen? This 10 would become what? 1. This 10 would become 1. So let's see if we can do this in order of 1 time, using the modulus concept. So you have what? You have 388, and you have this thing that you have to divide it by 9. So let's do it. So if I do it, so what will I get? I get 3 4s, 9 4s are 36. So this is what I get. Then I get 28. So 3 times I take, so 27. I get 1 as the remainder. I am getting 1 as the remainder for this. When I divide it by 9, and you can observe that the remainder, that is 1, I am getting here. This is the same thing that I get as the final answer. This is something that I am getting the brute force way. First of all 388, then I move to 199 by taking the sum of digits, then I move to 10, then I move to 1. This is a brute force manner. It will take more time. But this was simple observation manner, order of 1 time. You just have to find the remainder. If the remainder is 0, then you do what? You just simply return the, if the remainder is 0, so you return 9. If the number is 0, so you return 0. If the number is anything else, so you return number modulo 9. This is what you do. Let me show you the code part for this particular approach. It's order of 1 complexity. So that means nothing but if the number is 0, so you return 0. If the number modulo 9 is equal to 0, if the number is divisible by 9, so you return 9. As I have told you, like if you have 18, so in that case sum of digits would be 9, right? Something like this. If you have, let's say, something like a 729, if you have 729, so finally the sum of digits would be 9, it is divisible by 9, so you will return 9, not 0, right? And otherwise you will return number modulo 9, because that would be the final answer, right? This is an observation based question. This is an observation based question, and this is not a trick. Believe me, many people will say that it's a trick, but it's actually not a trick. It's an observation that you have to do, right? That the final answer is lying in the range 0 to 9, so you can always take the modulo 9, or you can maybe draw all the cases as I told you. Like I draw it from n is equal to 1 till n is equal to 30 or something like that, and we observe the pattern. Please give me a +1 in the chat if the approach is clear to everyone. I'm here for 60 minutes more. You can tell me if you haven't understood it, or you can tell me if you have understood it, right? So we discussed this particular problem using two approaches. One, please give me a +1 in the chat, right? One was a brute force approach that we did, that is you keep on taking the sum unless and until the number is a single digit number, right? The second approach was an order of 1 approach, and it was very basic. It is also known as digit root approach, right? But forget about the name. It's also known as the digit root approach, but that was basically taking the number modulo 9 and observing what is happening, right? And now this particular question, as I told you, it was asked in companies like Microsoft. It was asked like this is, if you will tell the interviewer that these are the things that you are observing when you are in an interview, when you will tell the interviewer that these are the things that you are observed and this is the way that you will get it, you will say, if you will say in the interview that this is a trick, so interviewer will reject you after that. This is not a trick, this is an observation, and that is what the interviewer wants from you. He or she wants to see whether you are able to make some observations, some rational thinking or not. Okay, why only mod 9? Why not any other number? Like no, because the answer is lying in the range 0 to 9, and this is observation. Like as you can see, like it will never be anything other than that, because the sum of like the highest can go, the highest single digit that I can have is 9. Okay, so can you tell some other questions follow the similar approach? Maybe you will submit the question, so in that case you will get some problems, so that those questions will help. Like Microsoft, it has also been asked in Adobe, and it has been asked in Amazon, right? These companies have asked this. Whenever you submit the question on LeetCode, that happens. Like whenever you submit a question on LeetCode, let's say I submit this problem, so what I get is I get this thing, right? Sum of digits in the minimum number, sum of digits of string after convert. So all these questions you can try, because LeetCode suggests this, because these are questions that are based on similar concepts. So Deepak, you can try out these questions. I hope that the observation was clear to everyone. If you liked it, you can share it with your friends. You can subscribe the channel if you haven't. So this is our channel Codera. I'm every day taking, without a break, without any holidays, I'm taking, irrespective of the fact that there's lightning, there's anything, I'm taking the LeetCode daily problems every day. So you can consider to subscribe this channel, share it with your friends if they are also interested in DSA and competitive programming. Thanks a lot for watching, guys. I'll see you soon in the next live. Till then,